And today around 4 o'clock, Advanced Tech, the Chief Technology Officer, will come here to give the talk and will tell us the latest progress of IoT technology. Before that, I will spend around 1 hour to review what you have learned in the past 3 lectures. Let's get started. So in the beginning, we want to model strategic interaction in an ecosystem. In the ecosystem, we have capital N players, and putting all together, these N players, capital N players, they can create value for capital V. This is the maximum value they can create it together. At the same time, we need to have input information for vector V. The vector V is a set of the maximum value for each sub-alliance or supply chain or value chain in that the players can create together. But those players are not entire total number of players, just subset of some players. So when we want to do strategic interaction in an ecosystem, we only need to have 3 inputs. Now let me do some formalize the ecosystem language. So capital N is a set, includes N players, the first player, second player, to little n players. And V is a vector that has all possible values generated by each independent supply chain. Okay? And when we know we have N players, and these N players can generate 2 with the power of N minus 1 possible configurations of supply chains. And why we want to minus 1? Because that 1 refers to the empty set. And now I want to make some definition. The N equal to the number of power set minus N, minus 1. Why? Because I do not want to count the alliance with total number of players. So now, let's do some formalization of power set, or called possible configurations of value chains or supply chains. Now I have M possible configurations of strategic alliance or supply chain. And the capital O is the largest one, having all the players. And in our last week's slides, you can see sometimes I put this means excluding N. So the power set excluding N, capital N equal to the number of configurations of supply chain excluding the entire ecosystem. So it's so far so good. Now I put some notation here. The little v of capital N actually is capital V. So actually they are equal to each other. You can start to imagine little v as a function. If I tell the function little v how many players in my ecosystem or supply chain, what is corresponding maximum value generated by the players or agents in this supply chain. So if I say that all the players enter to the supply chain, capital V will be the value. If only G1 players enter the supply chains, the V of G1 will be the value created by the group G1. Is that okay? So far, so good? So I follow the Joe's suggestion, so I put an example here to help you understand what I'm saying. Now, if I want to understand the ecosystem with 3 players, Amazon, Facebook, and Google, and you know we are very good quantitative consultant, so putting Amazon, Facebook, and Google are too wordy for us. So we use 1 for Amazon, 2 for Facebook, 3 for Google. So now how do we use power set language to formalize possible configurations of supply chain? So we will know we have 7 possible supply chains, such as 1, 2, 3 as one supply chain, 1, 2 as the other supply chain. Or each of them just work on their own. Amazon on its own, Facebook on its own, Google on its own. So we have 7 possible supply chains. Excluding the largest one, we have 6 possible supply chains. They are subset of our power set. Is that okay? Any questions so far? You need to be very careful about definition because later we will use a lot of set theory and logic. If you misunderstand the definition, you will not get a result. And today we will derive some laws of business model. Okay, so I can convert this mathematical language into a table. If you learn management science models or optimization, you can see I create this table for linear programming for the later on analysis. So now I have 7 groups, so I put them here. And I have 3 agents, Amazon, Facebook, and Google. So I get 3 columns. And you can see I use 111 means the first group, that's the largest ecosystem. I use 110 means the G1 ecosystem has Amazon and Facebook. So 111 is one configuration for supply chain. 110 is the second configuration. 101, Amazon and Google is the next supply chain configuration. So we create 7 possible supply chains. And if we can create function of little v, that is function of maximum value generated by the input of number of players in your ecosystem. So in this case, we have 200 for larger one, and 100 for the second configuration, and 150 for third. And the rest of them just 0. Is that okay? I put the blue color letters for the mathematical notation. So you can start to compare the mathematical notations and also the numbers in the table. So any questions so far? So is that clear? Okay. Now, we start to do some matrix operations for later on linear programming analysis. So I want to define an indicator matrix. I use 1 underline for vector. So 1 underline n actually is the supply chain configuration for all the players involved. So it's 111. 1 underline of G1 is the second possible supply chain with only Amazon and Facebook. Is that okay? So I will be able to use 1 underline of G to present all possible sorts of value chain or supply chain or strategic alliance. When I put all these possible supply chain together, you can see this the first possible configuration, second possible configuration, third possible configuration. At the end, it becomes a matrix. This matrix has all possible configurations of supply chains. Okay? Now, I want to further explain the difference between traditional business models and our perspective. We start to look at business model 101 as what you learn in very basic business class. If I pick up one value chain or supply chain configuration, for example, G1 configuration, and I know there are 2 players here. One is Amazon, the other is Facebook. If Amazon as a seller, Facebook as buyer, and I think you will learn this in your management class. Now, I can calculate that value creation for you to know your value principle in the business model. And you also can learn this in the business weeks and the other business magazine. So everyone can know it. So now, there's a cost for Amazon. And net utility is the consumer utility for Amazon, for Facebook. So now, if we decide price for selling goods from Amazon to Facebook, and we will say the difference between utility and the cost is value created by the transaction between Amazon and Facebook. Now, do you remember in the week 2 slides, how do we calculate utility in the value principle at any business model. We use willingness to pay by customers. You get this data from survey, minus the price offered by seller. You get the net utility for consumer. So this is the part consumer get, the green bar. The next is, how do we calculate the profit of business model? That's easy, and any high school students know how to do it. Price you offer minus cost produced for your product times flow rate, that's how many products you sell to your customers. So price minus cost times flow rate is the profit for your business model. Does this make sense? However, this perspective only considers the side of value creation. We learned this in the Management 101 and Business class or Economics 101. We all know it. Transaction created value, but it only considers the side how value created. Does it consider how much value each agent or players got in the ecosystem? It says nothing. You may get zero value in that transaction, such as Xerox created Windows system, but it got zero profit at the end. And Apple and the Windows get everything. So you create it, you may not get it. The reason is, if we only consider value creation from this simple view of product price focus, the inside value appropriation between agents are implicit, and we do not know any insights from this diagram. Okay, is that clear? So this is what I try to say. Value principle or value proposition or any this diagram you saw in the business model textbook or management textbook say nothing about how much value you get. So you have no idea whether your business model has competitive advantage or not. It says nothing about competitive advantage. Now, if you take this concept about the focus of product price cannot tell you anything about competitive advantage, we start to move to a better way to look at it. We first look at what do we mean ecosystem. If we have more players enters in our value chain to create value, not surprisingly, we should think the value they create together should be better and greater than their individual values on their own. So this observation gives you some basic idea. VG1, Amazon and Facebook co-create the VG1 value should be greater than the independent value by Facebook plus independent value created by Amazon. So are you okay with this assumption? Ecosystem should lead to bigger value than independent value. We call this as super-additivity assumption on value creation. We can write it formally. For each group G and G prime, which are subset of capital M, such that the intersection of G and G prime equal to empty set. That means they have no any intersection. If that is true, the union of these two disjoint sets, its value is greater than independent value from each members in those two subsets. So I do not change too much. I just use more general notation to describe this example. So if you understand the example, and you should understand what we say about assumption of super-additivity. So they are the same thing. Is that okay? If you start to appreciate the super-additivity assumption, actually it's the ecosystem perspective. Now we want to have more complete perspective to look at interaction among agents to appropriate value. So this assumption leads us to use value appropriation principle. As you see, more agents involved, better than the subset of them to create value. In that case, product folks' view tell us nothing how agent to appropriate this value. So we want better ideas. Now we move to value appropriation. So far we already finished setup of value creation using what you learned in basic management and business textbook. Okay. Now this confusing part, you may spend time to look at it. If we have input for analysis that are capital N, capital V, and the little v, number of players, total value generated by them, and the value of each subgroup in the entire ecosystem. I hope to get output as an A list, which is a distribution of values, how much value captured by each agent, called pi. So pi is a vector. This vector tells us the value captured by agent 1 is pi 1. The value captured or appropriated by agent 2 is pi 2. And pi n is the value captured by agent n in the ecosystem. So that is unknown, is what I hope to get at the end of analysis. So pi is the value appropriated for each agent. Is that clear? So that's output. It's unknown so far. We start to look at assumption 2. If now we want to imagine what sort of restriction on these outputs, the first will be feasibility. The summation of each player's pi I should be less than the total value they create together. This should be okay, because your output cannot be greater than your input in any physical system. Is that correct? No one can generate more than system's upper limit. Okay. So this assumption simply just say, if now I know how much value appropriate for Amazon, Facebook, and Google, the sum of them need to be less than 200 as a total value generated by all of them. Where 200 from? Is, in my example, I say the largest value for all of them to co-create together is 200. So that's why feasibility assumption just imply this case. Okay? So we just warm up. Later we will do more brain massage. So we need to be very clear about this assumption. Now move to assumption 3 for stability on value appropriation. Sometimes in the journal article or business book, we call it competitive consistency for stability. So it say for any subset in the ecosystem, the summation of each players in a subgroup G, that value summed up together need to be greater than the independent value generated by original subgroup. It is saying if you want to induce agents to participate in a bigger ecosystem, such as capital N, at the end, each of them should get value appropriate more than their original opportunity cost from not joining the entire ecosystem. We look at example here. We have a G1 subgroup or G1 supply chain that has Amazon and Facebook. If Amazon's profit plus Facebook profit less than original value they have, 100 as opportunity cost, then what will happen? We look at here. This is our example. If Amazon and Facebook, they do not participate entire ecosystem for 111, actually it's capital M, they just stay their original supply chain. the value for this particular supply chain is 100. And as you know, following the logic we learned in high school, I want to test this assumption. So I suppose opposing statement. If they get value less than original what they have, what will happen? For any J, such as Amazon or Facebook, they can do better by doing what? Pi1 plus Pi2 less than VG1. So they can have this Pi1 here. They use their original independent value, VG1, minus Pi1 plus Pi2. So you can see there is a positive gap. Does this make sense? And this gap divided by number of players in this particular value chain. That's the 2 here. And we get the positive number divided by 2, which is still positive. This positive plus Pi1, where you get in the entire ecosystem, is greater than, so you get a new value, pi I plus this part, the positive thing, you get pi j hat. So it's for example, here's pi 1 hat. This is greater than pi 1. And in this case, what Amazon will do? Amazon will reject to join the ecosystem. Is it? Because stay in the original sub-supply chain is better. Okay? I think because so if this happens, that means your feasibility assumption has been violated. So VG1 can minus Pi1 plus Pi to get positive number. So just take a little bit this positive number into what you get in the entire ecosystem. And you will know, actually stay in the original supply chain better, so I don't want to join. Is that okay? Can you see this? So it tells us feasibility assumption is very important for all the members staying in the entire ecosystem. Otherwise, they want to stay in their original supply chain. Now, we move further. We have feasibility assumption and stability assumption. That implies the sum of each agent's pi in the entire ecosystem, capital N, should be equal to capital V. The reason is we look at assumption 2 for feasibility. This is greater than. And for assumption 3 for stability, this is less than, here is greater than. If you want to make less than and greater than work together at the same time, equal is the only choice, is it? So that's equal. If you remember what we use for metric operation, we can say one underline of capital N for the entire ecosystem times, this times is a cross product in matrix operation, times the vector pi. Pi is the value distribution for all the value appropriate by each agent, pi1, pi2, pi3. That will be equal to V. In our example, capital V 200. So we can use this matrix notation to replace the summation here. So our form will be neat. As well, usually we learn in engineering school and science school. Now, we do further. You need to have thought on this. If super relativity and stability together imply for all subgroup, including agent I, so I write this statement. For each subgroup having I, which is a subset of entire ecosystem, capital N, these two, because we have this feasibility assumption, the sum of each agent in any subgroup greater than their original value in their original value chain. So this makes sense. due to superiority assumption in A1. Now I make a little theme. If I take I, the player I, out from the group G, because of pseudo-relativity, the summation of the rest pi having no I still greater than the value in their original supply chain. Does this make sense? This is easy. We just use stability assumption. Okay? But here, I take I from G. So you can imagine I took a pi from this summation. In that case, the VG minus I will be the value generated from the group without I, should be still less than the distribution value. The reason is just I apply super-relativity assumption. So this is just direct implication of super-relativity. Now we work on the next part. So we put everything together from assumption 3, the stability. So we can see G underline is a matrix has all possible configurations of value chain or supply chain. Pi is a distribution of value appropriated times together as cross product will be greater than the total possible value generated by each supply chain. So I just rewrite it, the assumption 3, using matrix form. If I put feasibility and stability assumption together, it is saying each agent in ecosystem faces an implicit tension. So there's tension between A3, the stability, and A2, feasibility. So these two assumptions create a tension in your ecosystem. Now let me work on here. We look at stability assumption. Pi I is a value appropriate by agent I. It should be greater than pi I hat generated by any other supply chain with I. So simply speaking, your ecosystem should give you the value greater than other value chain or subgroups, the value to you. So pi I is an entire ecosystem to give you this value for agent I. For the other supply chain, I'll give you an example here. Now I want to calculate the Amazon's value capture. So I want to know the entire ecosystem, 111, how much pi they give Amazon. At the same time, we can see the G3 and G5, they also have Amazon there. I want to know how much value they give Amazon. I call pi I hat. This pi hat needs to be smaller than pi generated by capital N. So simply speaking, that is stability assumption. If you get used to this idea, what it's saying, all the other groups, including agent I, which is Amazon, they try to compete for Amazon. So they give Amazon more options. So the other possible configurations say, Amazon, don't need to join entire ecosystem, join our subgroup. Or the other configurations say, Amazon, don't join them, join me. So at the end, they all compete for Amazon. We look at this case. Amazon can work on its own, or Amazon work with Google for one configuration. Amazon work with Facebook, or Amazon work with everyone. So in this 4 configuration, Amazon is always there. So the bargaining process for them to compete for Amazon decided the minima value appropriate by Amazon in the ecosystem. Can you see this? And this result is generated by assumption 3, the stability. Okay? So I think competing for me, this part is easier. But the other side of tension actually is less intuitive. Do you remember we have the A2? A2 is a feasibility assumption. So what we learn from feasibility assumption is we have capital V that limits agent I's value because the sum of values together in the entire ecosystem is less than capital V. So let's do some simple algebra. Now I'm agent I. My appropriate profit should be less than V minus summation of pi whose are not I. So I think this should make sense. So we look at further. We have the stability assumption. So it also tells us this part, the summation of pi that have no I, this summation should be greater than the value generated by that group. So simply speaking, capital V limit the value potential for agent I. And if there are the other groups or the other value chains that have no I, and when those start to form together, they get more pi. The more pi they get in their supply chain that have no agent I, and it will squeeze the entire value pi I will get. The reason is this is fixed. But now they form their supply chain without I, so pi j get bigger, bigger, bigger in their value chain. And then they squeeze the value of pi I. Okay? So the other side of competition is without I, such as Facebook on its own, Google on its own. Facebook work with Google. So all their alliances, all value chain or supply chain limit Amazon's value creation potential. So through the feasibility assumption and stability assumption, one assumption creates the agent I has minima value appropriated. We call pi A minima. But for the other side, competition for the feasibility assumption, this is stability assumption here. This stability assumption. Here is feasibility assumption. Feasibility assumption limited I's value creation potential. So this will decide pi A maximum. A is Amazon. So these two assumptions put together at the end decide the range of competitive appropriation for A. So pi A is falling into this range. So these two assumptions create this tension. Now, let us make conclusion. And if you learn this, if you get this insight, I think you already learn a lot from this class. So we all start from very general assumption as you learn in the physics or engineering. So these two, there is only one force of competition rather than 5 or 6 or 7 or 8 or 9 or 10. If you start to look at the report from BCG or McKinsey or whatever consulting firms, always give you 2x2 matrix, 3x3 matrix, and now not only 5 forces, now I add the complementars in the value net. So they add more and more components, let you to draw the matrix. You start to put ingredients into the matrix, you say, I finished the job. And this insight tell you it may not make sense at all. The reason is only one force from the tension. If you are complementary, for example, Google is a complementer for Amazon. Complementer can be both sides. Your competitors also can be on both sides. So we should not use more complementers or more innovators or whatever to complicate your analysis. if you look at entire ecosystem, the true competition is only from the tension between compete for you and compete without you. So with you versus without you, only one force, not 5 or 6 or 7 or 8 or 9. Okay, is that clear? Now we look at inside 2. So with the assumption 2 and assumption 3, it leads to one conclusion. The appropriate value is between a range, pi minima and pi maxima. So if any value satisfy this condition, for example, if any value appropriate satisfy assumption 2 and 3, we call it as a competitive distribution. That means all the values satisfy assumption 2 and 3, they should be possible value appropriation outcome. Okay? So why this is important? We start to look at inside 3, and I will go back to say, pi actually is a distribution, not a point. The reason is here. Have you heard about competitive intensity notation in your management education? So if you learn economics or management, always say you want to do industry analysis. First, analyze how competitive in that industry. If that industry is close to perfect competition, you should not enter because you will get zero profit. And is that correct? We first try to measure what is competitive intensity. If we look at competitive intensity as a length of pi I maxima minus pi minima, the range between your maximum value and minimum value. So somehow we can say if the competition in this business sector is very intense, that means very competitive, it refers to pi minima equal to pi maxima. So competition itself decides how each agent appropriates a value. So there is no any room for negotiation. Competition is extremely intense and perfect. So everyone gets result from competition. So in that case, it's really intensive competition, very intensive competitive industry, so bad. With first case you learn in Economics 101. If pi minima equal to pi maxima equal to 0, or VI, that is the next best alternative for agent I, or opportunity cost for agent I. If this happens, I would say what you learned before is right. This industry is so bad, you should not enter. But in the other way, if pi I minima equal to pi maxima equal to capital V, such as diaper in commodity industry, if competition perfectly decide how much you get, and this value equal to entire value created in the industry, such as petroleum oil or some monopoly industry, is competition is so bad? Actually, no. Competition let you get everything. So intensive competition is neither bad or good per se. The third insight we get is competition can be a good thing. So you can see some giants working in very intensive competitive industry, but they earn most profit. If we get this wisdom, we can start to better define perfectly competitive markets as what we did in last week. Pi I minima equal to pi maxima. Competition perfectly decide how much value each agent got. Okay? We look at the other case. If pi I minima equal to 0, pi maxima equal to V, in that case, your competitive range of pi is entire value creation. In this case, competition plays no any roles. So competition cannot decide how much value you get. It is possible. So competition can be good or bad, but competition can also not determine the outcome if the range is so big. Now, as you know, now is a big data era. We want to do the very good cutting-edge business consultant after graduate from NTU BA. How do we better measure competitive intensity using your high school math knowledge? Okay, this is not in our reading. Let me help you to develop your skills of doing data analysis. From our definition, competitive intensity is proportional to 1 divided by the range of pi maxima minus pi minima. Are you okay with this? So I somehow, from the word verbal definition, I can say competitive intensity is proportional to this. Now let me do some simple math. If I create new parameter or new variable called 1 divided by pi maxima pi minima, actually here, I call this as h. I make the other variable g, gi equal to natural log of hi divided by 1 minus hi. So I create the other variable called gi, and from what you learn in the high school with natural log and exponential, and we get this outcome. I will be able to calculate ci equal to exponential gi divided by 1 plus exponential gi. So I use 2 steps parameter transformation. I will calculate the index for ci, and that will between 0 and 1. Is that okay? So as a data scientist or business consultant, we need to create a lot of measures. Sometimes the competitive intensity is a concept. I just show you a way to use simple math. And how do we create this in our statistical analysis? Now we move to next insight, insight 4. We already know the value appropriated for agent I is between pi minimum and pi maxima. So these two, the final value realized by appropriation will be equal to pi minima plus fi times the range. Are you okay with this? I can use a more technical way to say it. It says that if you learn in economics or you learn in the instructional engineering, you may heard about the convex combination. Okay, I don't want to complicate it. Actually, we know if pi minima to pi maxima, this interval is convex. And any value inside this convex combination can be represented by this linear formula. So this is a property of convex combination. Okay, you can forget what I say. This just, if you learn in engineering school, they will teach you this way. But here, we can say, simply speaking, because pi is between pi minima to pi maxima, so I can find out one of I. Of I is less than 1, greater than 0, and pi can be any value from this formula. Is that okay? Now, I want to give the other insight. Usually, we call fi as appropriation factors that consider to induce other agents to part with the value beyond the implication of A3. A3 for stability, and we know if with A3 we guarantee minimum value we get. Okay? So for any value we appropriate more than pi minima, and that will be controlled by fi, but fi is out of control of competition, is from the other resources we'll mention in the later lectures. Okay, so far we concluded 4 insights. That's already very useful. And we can move to some laws. Sometimes I like to get general principles or laws from the model assumptions. Such as in a high school, I think you like me like physics. We all know F equal to ma. If we build some assumption, what F equal to ma tell us? It tells us the best case of a motion, the system moving. So it's a motion system. So if we do it right way in our model setting, we should get some result for best case performance and worst case performance for pi. Pi is unknown in our analysis. We can find out what the best situation pi would be, what the worst situation pi could be, and in physics and engineering, we call them laws. Now we want to create law. In any management book, we always call added value. This informal idea in management textbook was from Brandenburg and Stewart, 1996 paper. That paper has no any math. And Brandenburg and Stewart, they write down this description in their strategy statement. Brandenburg and Stewart say, added value of player equal to value created by all players in the ecosystem minus value created by all other players. With our formal definition, we can define it in a formal way. The first definition is added value, AVI, is capital V minus the value generated by the entire group, excluding I. So if I take off I to form a group called capital N minus I, its value, the V take off this value should be my added value. So it's just the same as what I wrote here. I just use notation to say it. If you accept this definition, we get our first law, opportunity cost law. Pi I minima, if you take this definition, still not related to here, with our stability assumption, do you remember your pi minima, the minima value you should appropriate should be greater than your opportunity cost. And opportunity cost can be also called next best alternative. So the first law in our system is pi minima greater than opportunity cost. With added value definition, we move to our second law, best case performance, BCP. Added value is from the difference between the entire value and the entire value without me. So the value I appropriated cannot be greater than added value. So added value defines the best case performance for pi I as F equal to ma define the best case performance for motion without considering friction. Okay? This makes sense. So this is best case performance. So if this is not true, what will happen? If pi I greater than added value, then we get summation for the value from the group excluding I will be less than Vn minus I. Okay? This violated the stability assumption. So this definitely needs to be true. So the BCP law needs to hold. Otherwise, our stability assumption cannot work. If you take all this understanding, we move to the definition of absolute competitive advantage. Simply speaking, competitive advantage refers to if you join the ecosystem, you will definitely get something. You will not get less than your opportunity cost. So formally, we can say pi minima greater than I's opportunity cost. So this is a formal definition of competitive advantage. Does our added value law tell us anything about competitive advantage? So we pay attention to this part. Around 2000, I learned management for business models and industrial analysis. I still remember what my teacher told me. If your business model or the industry you locate let you create extra value, and you have competitive advantage. So if you read the Commonwealth Business Week, always say, okay, this company created value, so their value proposition is right, and their business model is sexy. Is that true? Now I tell you, actually, maybe not. added value does not imply you have competitive advantage. Why? With the added value law, let me start with BCP law. BCP means here, if you have added value, this is greater than, added value is greater than pi maxima. So if you have absolute competitive advantage, okay, pi minima greater than your opportunity cost. So this part for your competitive advantage statement. If ACA is right, this definitely will imply the BCP law is right, yes? The reason is pi maxima greater than pi minima, and the AVI greater than pi maxima. If here is true, then it says competitive advantage, you can see ACA is here. Now we place some necessity and sufficient condition. I know lots of it confuse you, but now I want to be very careful here. So if ACA is true, if I has competitive advantage and I has added value greater than opportunity cost, so BCP law is right. But put it reversely, added value here is a necessary condition for competitive advantage. In other words, added value is required for ACA. Let me say it again. If a firm has competitive advantage, and definitely it has added value, but added value does not guarantee competitive advantage. So it says competitive advantage leads to BCP law, okay? But BCP law, actually added value you learn in the management, cannot guarantee you have competitive advantage. Why? We look at this diagram. If you say, now your business model create the value, so you start have value proposition. You have proposals, say, okay, my product has many features. I can charge this price below to utility for consumer I create, minus my cost. So this is my value proposition, okay? So your value proposition, your business model statements create BCP law. But if BCP law holds, is it possible to get VI minima just equal to opportunity cost? It's possible. Yeah, because BCP law only say relationship between VI maxima and AVI, say nothing about VI minima. VI minima, so here's pi. I made a mistake. Here two are pi I minima and pi maxima. Correct it? Here's pi. This is pi. This law, usually you use in your strategic analysis or your business model statements. You make value proposition from BCP law. But BCP law cannot guarantee your pi minima is here, here, or here, here, or here. If your pi minima equal to your opportunity cost, what it says, that means your value proposition may lead you not better than your opportunity cost. Is that possible? This is possible. Okay? So added value is just a necessary condition, not sufficient condition. Now, if you take this concept, we move to the next definition. If pi I equal to added value, I will call I is a full appropriator because added value is the maximum value I can get from my value proposition. In that case, if pi equal to AVI, I get all the value I created. That would be lovely. And this will lead to the law of adding up. I call GP2. What's the law of adding up? If all the agents in the entire ecosystem got their added value, then the sum of the added value equal to capital V, entire value they generated. And I can tell you, I guarantee pi I minima equal to pi maxima, pi I equal to pi minima equal to pi maxima equal to added value. So we create sufficient condition. This is stronger than what we need. If the sum of added value together equal to V, because no any agent can appropriate more than the added value. So this generated outcome, everyone is full appropriator. And in that case, this is perfectly competitive market. So again, this is sufficient condition. So I can say when competition is perfect, and pi I minima equal to pi maximum equal to added value, adding up law guarantee this market is perfectly competitive market, but this condition is not required for perfectly competitive market. So now we move to next definition. We mentioned last week. So far, you can see added value does not help at all. It seems quite helpful, so we all use it in our business model development, but it tells us nothing about competitive advantage. Now, what can we do? So we all know value creation, added value, but it offers nothing. We define a new variable called I's minimal residual. So we use capital V minus added value, minus the sum of added value from the group excluding I. So I change it the other way. Minimal residual actually is known if learning added value. So if we get added value, we can calculate MRI for each agent. So MRI actually is the smallest value the agent I can get. The intuition is straightforward. No one can get their added value. If all other players get their added value, and MRI is upon everyone get the best. So what I should get should be greater than MRI. So that's a residual. Does this make sense? So we move to the minimal residual law. And this is much more lovely. We all should get more than our minimal residual. So minimal residual actually is a worst case performance in engineering and science sense. So minimal residual is the worst case I should get for each agent. So it defines the lower bound of competitive distribution. No one should get less than that. So if the worst case I will get greater than my opportunity cost, of course, I have a competitive advantage. Is it? The worst case I get better than the next best alternative. I have competitive advantage. If I join the game, I earn something. Is it? So this is worst case performance law. Now we start to look at here. This is a sufficient condition for competitive advantage. We start to see if we have positive minimal residual, that means minimal residual greater than my opportunity cost. And MRI should be here. I already know pi minima should be greater than MRI. That this makes sense. Why? Because I always get them more than minimal residual. So this implies pi minima greater than opportunity cost. So I have competitive advantage. That's what we call sufficient condition. But why this is not a necessary condition? We look at here. We change it the other way. If firm I has absolute competitive advantage, it says pi minima greater than opportunity cost. Okay? But where is MRI? MRI can be here or here. So absolute competitive advantage cannot guarantee MRI greater than opportunity cost or not. So I cannot turn the condition back. That's why I say the MRI guarantees competitive advantage, but not required for competitive advantage. If you have competitive advantage, if you have competitive advantage, MRI still be possible occurred here, even you have competitive advantage. So this is sufficient condition, not necessary condition. So we quickly wrap up. So we talk about intuition. When other participants add meager value compared to I, implicit competition for I is high. That guarantees I to have absolute competitive advantage. I translate this into plain language. We look at this condition. GP3 say, if MRI is big, okay, MRI is the worst case performance I will receive. But if it is still big, it implies other agents contribute to the ecosystem with very small amount of value creation. It's meager. If my MRI is very big, that ACA becomes true, refers to other agents create less value to entire ecosystem. In that case, I have higher chance to have competitive advantage. So in sum, with the formal definition, now we already get some, like the MRI, the minimal residual law. We don't need require many information. We can calculate whether a firm or business model has competitive advantage or not. But there is a better thing. Very possible we only get GP1, that means necessary condition is right, and we also get sufficient condition, but we still have no idea whether the firm has competitive advantage or not. It will occur. The reason is this is basic case performance law, AVI greater than VI. In that case, added value greater than opportunity cost. But MRI, minimal residual, less than opportunity cost. In this combination, we cannot guarantee whether firm I has competitive advantage or not. We do a calculation, so you will start to see what's going on here. So this is our last example. We back to our original example. Our formal definition for ecosystem create this table. The first, I calculate added value using the GP1 law, added value law. So I start calculating added value. 200 minus the group without me, that is 0. So 200 minus 0 to get 200. I follow the same way. I get added value for agent 2, added value for agent 3, which is Google. This is Facebook, is Amazon. The sum of all added value does not equal to the total value. So I cannot state whether this market is perfectly competitive or not. I can't, because the GP2 law does not satisfy. We move to the law of GP3, the minimum residual for worst case analysis. We start to see how do we calculate worst case. We use the total value, 200, minus the added value from rest players. In this case, 200 minus 50 minus 100, I get 50 positive minimal residual. In the other case, you can see 200 minus 100, I get negative 100 for minimal residual. So I get negative minimal residual. So I cannot say the Facebook has competitive advantage. Applied to the Google, I get negative 50. I also don't know. So far, our three laws guarantee Amazon has absolute competitive advantage, but the other players, I do not know. And this market is not perfectly competitive, okay? But it is or is not. We need to have better analysis told in the following lectures. So we've already finished the review of formal setup. I quickly go through today's conclusion. So in the CBA, I already upload 2 project examples. They are written from the previous MBA students in Melbourne Business School, and they are the benchmarks for the group project developed in this class. And we also put a number of video clips for you to know how to develop better IoT product, okay? And today we already give formal definition of value appropriation, and you also have our tutorial to follow to create dashboard for your IoT product. I want to talk about background reading. If possible, in the next 2 weeks, I really suggest you to read this measurement science paper. Spend 3 days on it. You will go through all the steps in a very clear sense to know what's going on. And I also put one trans reading to describe the previous case happening at Advantech. And this publishing in National Taiwan University Management Review. It has very long English summary, but I need to say the main body is written by Chinese. In this case, if you do not know Chinese, I suggest you to read English summary. And later, I will assign you to different groups. And you can discuss with a group member to understand the history of Advantech. And this is optional. Okay, and use the example 1 and 2 on CBA as a benchmark for your group assignments. And that's it. And thank you for coming for today's talk. And we take 10 minutes break before move to our invited talk.